Today's lesson is on ellipses. I'd like us to start by starting with the diagram. I put 2 points in this diagram, each of which will be a focus of our ellipse. Plural form of focus is foci or foci, spelled F-O-C-I. Now, for an ellipse, halfway in between the two foci, we find the center of our ellipse. Now, what an ellipse is the set of all points, the sum of whose distances is constant. So, the sum of whose distances from the foci is constant. So, for example, let's say that this was a point out on our ellipse. Then if you add up this distance plus this distance, let's say it was 10 units, this plus that. Then another point on our ellipse, say it was here. If we did this plus that, it would also be 10. And say another point, this plus that would be 10. Say we had another point out here, this plus that would be 10, and so forth. And so an ellipse often looks like sort of an ovalish shape when you create it. Something like that. That's a pretty horrid ellipse. Let me try and get a little better curve. Something like that. Let me erase those points so they're not too distracting for us. All right. So often when you see an ellipse, you'll see something that looks like an oval. So we have the two foci here. Next, what I'd like to introduce is what's called the major axis. The major axis runs through the two foci in your ellipse. So the major axis would be this line segment going through there. Now, if I drew this ellipse perfectly, it would cut our ellipse in half. So let me try and make that look a little more like a cut in half oval. So this is our major axis right here. So then the minor axis also goes through the center, but it goes perpendicular to the major axis. The major axis is always the longer axis on an ellipse. The minor axis is the shorter one. In this case, minor meaning lesser. So minor axis here. If this were I'll just draw a quick sketch. If this were an ellipse that was sort of rotated around, so it was longer up and down than side to side, this would be the major axis, and this would be the minor one. So the major axis isn't always horizontal. It could be vertical, and we will see an example of that towards the end of this lesson. A couple other terms I'd like to introduce. Where the major axis intersects the ellipse at the ends there, those are called vertices. The singular form would be a vertex. V-E-R-T-E-X, vertices, V-E-R-T-I-C-E-S. So I'm just going to label them with a V here. Next, a few distances on this diagram are important. One of those distances is the distance from the center along the major axis to the vertex. So this distance right here. Now this should be exactly the same as this distance over here because it's in the center. And the letter that we use to represent that distance is the letter A. This distance is A, which means that this distance would also be A, and the distance all the way across would be 2 times A. This is also sometimes called, I think, the semi-major axis. This distance here, then, is B, from here to there. And so this distance would be 2B. All right. So, looking over at the definition of an ellipse is the set of all points x, y in a plane, the sum of whose distances from the 2 fixed points, known as foci, FOCI, is constant. Next, what I'd like to do is make a little note about this diagram. Imagine if we were to take this A value and start shrinking it. If we did that, then our ellipse would get narrower. Now imagine eventually shrinking this A until it was the same length as this B. So shrinking it so it's the same length as B, so about right there. If we did that, then we would have a shape which, going from the center up, would be the same distance from center up, center left, center bottom, center right. Ultimately, basically, as we did this, the 2 foci would draw closer and closer together as well, and we would have a circle because you'd have a shape, a figure that's the same distance from the center all the way around. So I'm just going to make a little note here. Imagine shrink A to the length of B. We're basically going to end up with a circle. Now, we're going to use that later in this lesson as well, so that's why I wanted to make that note. Now, let me see. All right, that should keep that mostly on the screen for you. Which I don't think I should need to do that. All right. So the equation for an ellipse, it's going to change depending on whether this major axis is horizontal, one side to side, or whether it goes up and down. For a horizontal major axis, like this one, we would use the formula x minus h squared over a squared plus y minus k squared over b squared equals the number 1. All right. So this A, again, is the distance from the center out to a vertex along the major axis. This B is the distance from the center out to the ellipse along the minor axis. H and K represent the coordinates of the center. So H, K is the center. And I made note of that up in that phrase above the horizontal major axis definition there. Got those notes there too. Next, if the major axis is horizontal, well, now I just noticed something actually. In your notes, you see how it says for a horizontal major axis twice. For the next one, for that second one, let's change that to a vertical major axis. So this one is for horizontal major axis. This next one is for a vertical major axis, one of those tall and narrow type up and down ellipses. We're still going to have x minus h squared, but in the denominator we're going to have b squared. We'll still have y minus k squared, and in the denominator we'll have a squared. And the right side will still equal 1. A note that I'd like to add underneath these two definitions is that the foci, these 2 points here, they lie, we're going to call that C units from the center. And we can find C by doing C squared equals A squared, which is this distance here squared, minus B squared, which is that distance there. And so this distance here is what we'll call C. All right. The eccentricity of an ellipse is a way to describe its ovalness, whether it is almost circular or whether it's like stretched out, more of a tall and narrow type thing. To find it, we're going to use the formula for eccentricity. E equals C divided by A, where C is found using this formula here, and then A is the length of the major axis, as we see in the diagram. Now, the eccentricity of an ellipse should always be between 0 and 1. So if you get something that's not between 0 and 1, then you must have made a mistake somewhere along the way, so you'll want to go back and check your work. All right, next up, we're going to pause here and then do those 3 examples at the bottom of your page. Our next task here is to take this equation and identify first whether it's an ellipse or a circle. Now, I told you earlier that for a circle, this distance and this distance need to be the same in order for it to be circular. But here I look in the denominator and I see that my denominators are different. That's going to give a bit of a clue here. Now, what I'd like to do is try and match this up to one of these 2 formulas. To do that, we're going to need to write our numerator in x minus h squared form. Now, in order for me to have x minus something equal x squared, I need to do x minus 0, since x minus 0 is what equals x. And this numerator would be y minus 0 squared. Now, this 16, to make it look like one of my formulas, is going to have to be a number squared. 16 is 4 squared. And so my A or my B is going to end up being 4. Now this 12 is not a perfect square. So what number times by itself gives us 12? Well, that number is the square root of 12. The square root of 12, when you square it, gives us 12. So square root of 12 is going to be either A or B. Now what I'd like to point out next is that square root of 12 is approximately 3.5. So my A and my B are going to be 4 and 3.5. So which one is this? Is this A and this B, or is this B and this A? Well, the major axis, this A number, is always greater than the minor axis, letter B. And so I know that this is going to be my major axis, and this is going to be my minor axis number. So this 4 is our A, and this square root of 12 is going to be our B. Now that we've identified A and B, we can tell whether this is a circle or an ellipse. If this were a circle, then these two numbers would be the same. But they're not, therefore this must be an ellipse. What we could have done right at the beginning of the problem is notice that these two denominators are different numbers. Therefore, our A and B will be different. As a result of that, it's going to be an ellipse. So if we had two numbers here that were the same, then that would be a circle. But this one's an ellipse. Now what we need to do is we need to answer the rest of the questions that we have. All the other pieces of information about this ellipse. So next up it says to find the center. The center is h comma k. Here's my h, here's my k, and so the center will be 0, 0. Next question is for the radius. The radius is something that we'll answer if it's a circle. So we're not going to answer that for an ellipse. It says identify the vertices. So remember, the vertices are these two sort of endpoints of the major axis on the ellipse. So how do we find those? Well, we know that the distance from the center to a vertex is a units. So then we can take our A, which is 4, and go 4 units to the right of the center and 4 units to the left of the center. Now, for this ellipse, our center is at 0, 0. So I'm going to be starting the sketch here now. All right, looks good. 4 units to the right, 1, 2, 3, 4, is 4, 0. And 4 units to the left, 1, 2, 3, 4, is negative 4, 0. So there's a vertex, vertex, and there's our center. It also asks for the foci. Now remember that the foci is c units away from the center, and we use c squared equals a squared minus b squared. So c squared is 4 squared, which is 16, minus root 12 squared, which is 12. C squared then is 4, and c is plus or minus 2, but we'll use the positive version and then go left or right. So the foci are c units away from the center. So we'll go 2 units from the center this way and 2 units from the center that way. And there we'll find our foci. All right. Next up, it says to find the eccentricity of the conic. Eccentricity is E equals C over A. C is 2, A was 4, 2 over 4 is 1/2. Last, it says to sketch its graph. We've got part of the graph done. We know that the major axis is going to go from here to here. The minor axis is going to be approximately 3.5 units from center to top and from center to bottom. So we're going to go up about 1, 2, 3.5. 1, 2, 3.5. And so then to complete it, we're going to go over to this endpoint of the major axis, up to the endpoint of the minor axis, endpoint of the major axis, endpoint of that minor axis. And there is a pretty lumpy, but good enough ellipse. So that's the first example. For this next one, I notice that the denominator is the same. I mentioned that when you've got the denominator the same and everything else is in proper format, that we're going to have a circle. So this is going to be a circle. Now let's go back and remember the standard form for a circle. X minus h squared plus y minus k squared equals r squared. To get this in the form of a circle, which we did back in the first semester, multiply both sides of this equation by 16. When I do that, I distribute 16 to both terms, and then the 16 will cancel with the 16 to the denominator, giving me x minus 3 squared. This 16 will cancel with the 16 to that denominator, y plus 2 squared. 16 times 1 is 16. So the center for this circle will be at 3, comma, negative 2, and the radius will be the square root of 16, which is 4. The other terms don't apply to a circle, so we just need to answer the center and radius for that one, and a sketch. Center at 3, negative 2, 1, 2, 3, 1, 2, center there, and then the radius of 4. So I'm going to go up 4, 1, 2, 3, 4, 1, 2, 3, 4 left, 1, 2, 3, 4 down, and then 1, 2, 3, 4 to the right. And we're going to have a circle, which doesn't look perfectly circular because of how I ticked off the lines there. I don't want to tick off lines too bad, though, because you don't want lines being too upset at you. So here is approximately what our circle would look like. So that's example 2. Next up, I changed the last example a little bit. Please note that I moved the 9/4 from the denominator of the first term to the denominator of the second term. I did that for important reasons. That way we've got more variety in our examples, as you're going to see eventually. So next up, if we thought of this as a fraction, put it over 1, I would see that we've got different denominators. That means that we've got an ellipse. Next, I'd like to put it in one of these formats here. So then, this would be x minus negative 5. And then this 1, I'll think of that as 1 squared. And that y minus 1 squared over, I have to think, what is 9/4? Or what number, when you square it, gives 9/4? That would be 3/2. That equals 1. Next, I look and I see which of these is greater, 1 or 3/2. And that's 3/2. So 3/2 must be my A number, and 1 must be the B number. Now what that tells me is that when A is underneath the Y term, that this must be a situation where we have an ellipse with a vertical major axis. So this is going to be one of those up and down ellipses. All right. Can you see it? Hopefully. Something like that. All right. Next. So this is going to be a vertical major axis situation. We answered that it's an ellipse. Next, find the center. The center is going to be found at the point negative 5, comma 1. we also want to find the vertices. Remember that the vertices are found at the end of the major axis. In this case, the major axis is going to be up and down because, well, that's what we determined earlier. So we need to take the A number and then go up that many units from the center and down that many units from the center. Doing a rough sketch, we'll have a center at -5, 1. Our A value is 3/2 or 1.5. So we're going to need to go up 1.5 from it to find a vertex. So it'll be about right there and down 1.5 from it to get another vertex. There's a vertex, vertex, center right there. So going up 3.5 units from the center, or 3/2 of a unit, 1.5 units, we'll add 1.5 to the y value of the center, and that'll get us 2.5. Then we'll go down 1.5 units to get -0.5. So those are the two vertices. Next, the foci. Use c squared equals a squared minus b squared. We said that a was 3/2, a squared is 9/4, b is 1, and so b squared is 1. Subtract, and we get 5/4 for c squared. And so c will be the square root of 5/4, which is the square root of 5 over 2. Yep, you should still be able to see that. All right, so then to find the foci, we're going to need to go up root 5 over 2 units from the center and down that many units. Let me pause here just for a moment to grab a calculator. Root 5 divided by 2 is approximately 1.1. And so we would need to go up 1.1 units from the center, and that would get us approximately y value of 2.2. And down that far from the center, which would get us approximately -0.1. Put us right in there. So we've got a focus just below the axis there. Now our minor axis, our b value is 1, so we need to go 1 unit away from the center that way, and then draw the ellipse. And there you have it for the ellipse lesson. I'll see you all in class.